Good morning, Fantastic Fours. Lovely to have you with us again. Still feeling very lonely here, all alone in my office with nobody to talk to. So I do just want to give a quick shout out to some people that I know are listening today. So to the grade 4 girls at St. Cyprian's, who I do teach, although not normally mathematics. I just wanted to say hi, and also to Kate in Hart Bay, who I know is doing maths with us today. Right. Just make sure that you have a pencil and paper with you today, because there'll be some things for you to work out. A reminder that I'm hoping that every day you're practicing your times tables and checking that your challenges are correct. And then just one more thing, my wife has pointed out to me that I use the word all right a lot when I'm doing these lessons. And I think that we're all lifelong learners and we need to learn and improve. So I'm going to make an effort. I know I've already said it once today, but I'm going to make an effort not to say it during this lesson. So while we're doing maths, you can keep an eye out to see if I'm managing to achieve my challenge for today. On to our lesson. Continuing with, before I go into the fractions for today, just a reminder that if you do want to get hold of me, it's grade 4 at WorksheetCloud.com. And after the lesson, to click on the homework to check that you have managed to master what it is that we're doing today. The link is above the video on this page. Fractions today. We're going to be looking at adding fractions. To start with, we're going to look at fractions that have the same denominator. But let's first recap what we've done so far with fractions, because we just come back from a long weekend, and then we'll look at what our goals for today are. So by now you should know what the numerator and denominator represent, the denominator being how many parts we've broken up our whole into, and the numerator, how many of those parts we have. We also looked at ordering of fractions when the denominators are the same or when the numerators are the same. And in our last lesson, we also looked at equivalent fractions. Goals for today, that you'll be able to add fractions that have the same denominator. And we'll also be looking to add fractions with different denominators by using equivalent fractions. We'll keep that part simple. That's the sort of next step up, but that's what we're going to be covering today. Let's have a look at our homework from before Friday. So the first part of the homework was having a look at whether you understood that a division problem is actually the same as fractions. So all I asked for you to do was to put the division into a fraction. I'm going to need to make this a little bit bigger so that I can see it all. Right. So the first one, all we need to do is say we need to put 7 over 8. There we go. It's a little bit small. I'll do the next one a little bit further away. For B, 5 over 9. For C, 1 over 3. So you'll be noticing that the numerator comes from the first one and the denominator comes from the second one. So the last one, 3 over 4. So 3 divided by 4. Looking at question 2, look at the following pairs of fractions, make them equivalent. So that should just be write them as equivalent fractions and then write the bigger one in the answer block. So first to make them equivalent, and second to then put your answer in the answer block. So for the first one, I notice that 3 over 4, I could make that 4 into an 8 by timesing by 2. And if I times the bottom by 2, I have to times the top by 2 as well, because what you do to the bottom, you do to the top. So this one then, I'm going to rewrite as 6 over 8, because 3 times 2 is 6, and 4 times 2 is 8. So that's where that 6 over 8 comes. This one, I'm not going to change him at all. stays the same. So the question asks me to write the bigger one in the answer block. So this is the bigger one. I will accept both, I will accept the answer as either this number here or this number here. Let me move this across a bit. Oh, I'm not able to move it without doing that. So let me just do it a little bit to the side. So you could either put your answer as 3/4, or you could put your answer as 6/8. Those being the same equivalent fraction, it doesn't matter which one you put. So both of those are the correct answer. Now that we've got that out of the way, let's have a look at the second one. Looking at the second one, I noticed that the 5 could be made into 10 if I times it by 2. And what I do to the bottom, I must do to the top. This one I will rewrite on the far side. 2 times 2 is 4. 5 times 2 is 10. This one I leave unchanged. Stays as 3/10. I wanted to write down the bigger one. That would be the second of the two. This one, or this one. And again, you can write either of those as your answer, either 2/5 or 4/10. That's an equivalent fraction. So both of those are actually the right answer. Shrink it down and move it a bit. Okay, having a look at the bottom part. Essentially the same, except that this time you needed to write the smaller one. Okay, so looking at the first one, I noticed that with those two, I could times the top and bottom by 4, and that would turn the fraction into 4/8. Compare that with the 5/8, which is unchanged. I can see which one is the smaller, because it says the smaller one. And the smaller one is either 4/8 or that. So our answer can either be 1/2, a half, or it can be 4/8. Both are correct. Looking at the next one, I noticed that if I times this by 3, which I must do to the top as well, I can get the same fraction. So the first one stays unchanged as 5/9. And the second one, 2 times 3 is 6. 3 times 3 is 9. Okay, this time the question is asking which is the smaller one. Smaller one is this one. Doesn't change, so the only answer it can be is 5/9. Right, I hope that you didn't have too much trouble with that. I said it. It's looking at equivalent fractions. Let's go back to our slides for today. So there are just two very important rules when it comes to adding fractions. And those two rules are this. Before we add, our denominators have to be the same. And secondly, we only add the numerators, the denominator stays the same. And I'll show you why that is in a moment. For the first few examples, we don't really need to worry about the first rule. I am going to remind you of it each time so we get into the habit of checking for it. But for the first few problems I give you, all of them are going to have the same denominators to start off with. Jumping back to our whiteboard, let's move down. So the first one I want to have a look at is this problem. 1/4 plus 2/4. Right, so I think I just said it again. Must get out of that habit. I can see rule number 1 says I need to check are the denominators the same. I'm going to write my rules on the side. Denominators the same. So I can check that. Yes, they are. And my second rule, we don't add the denominators. Let's draw this quickly so that we can see why it is that we don't add the denominators. So I'm going to draw them as squares. We're looking at quarters, so each of these will have 4 parts. In the first one, we have 1 quarter. In the second one, we have 2 quarters. What is it that we're adding? We are adding quarters. So if I look back at my 2 in the question, I can see that I have 1 quarter over there, a second quarter, and a third quarter. So I have 3 quarters. 1 quarter, 2 quarters, 3 quarters. I don't suddenly have 3/8. One, 2, 3. So you'll notice that the space over here with 1, 2, 3 quarters that ends up being that size is very different from what I've managed to get over here if I made it 3/8. So we don't add the denominators, we only add the numerators. I hope that some of you will remember that from before. Some of you may be able to do that. Now that we've worked that out, our denominator stays the same. So it was 4 in the questions, we're still looking at quarters. And 1 plus 2 gives us 3. So our answer is 3 quarters. Second question. We've practiced 1, let's practice a second. This time I'm going to look at 1/5. So I'll do this one with you, and then when we finish with this one, I'm going to give you 2 that I'd like you to try on your own. Plus 3/5. So remembering let me check the rules again. So with the first one, we also didn't add the denominators. So checking my rules. First up, the denominator is the same? Yes, the denominators are the same. So we can check that. Let's look at our second rule. Second rule, don't add the denominators. We're going to keep that the same because we're looking at fifths. Yes, we can tick that rule. Now we're going to add our numerators. 1 plus 3 gives us 4. There's our answer. Straightforward, quite nice and simple. There we go. Number 3, I'd like you to try on your own. I'll put it down there. I'll give you a head start. And a few minutes in, I will then go through it with you. This is the one I'd like you to try on your own. Give it a go. So remember to check your rules. First of all, are the denominators the same? Secondly, when you've done that, don't add the denominators. Okay, let's quickly go through this one. Well, we checked the first rule. Our denominators are the same, 7 and 7, which means we can put 7 as our answer for the denominator because that doesn't change. Second rule is correct. Now we add the numerators. 2 plus 1 gives us 3. Well done. If you got that, and don't stress too much if you didn't, this is about practice. Move my screen down a little bit. Number 4, the last one that we're going to do that looks like this. This one, 3/8 plus 3/8. I think I'll just give you 20 seconds to do this one. Remember to check our rules. They've slipped off the page, but first off, we check to see if our denominators are the same, and secondly, we don't add the denominators. I think you've probably had long enough to do this. Denominators are the same, and it stays the same for the answer. 3 plus 3 is 6. Straightforward. Let's jump back to our presentation. Here are our two rules. Now we're going to go to the next slide where suddenly we need to pay a little bit more attention to that first rule. Adding fractions which have different denominators. Up until now, we've only had to worry about the second rule. Now we're going to need to make sure our denominators are the same before we add. So what we're going to do is we're going to use equivalent fractions, which we learned about in our last lesson, to make them the same before we add them. These are the ones I'd like you to do. So I will work through 3 together, and then there are 2 that you will work on your own, and then I will go through with you. Let me put my rules down again. So let's change to blue. So the first one I'd like you to do, 1/3 plus 1/6. I'm going to give you quite a specific layout to use for this, and I'm going to do that while you're getting used to the process. So we're going to use equivalents to make the denominators the same. So first up, we need to make sure our denominators are the same. And because this one is a 3 and this one is a 6, we can't add them yet. So we've got to make them both the same. Now I notice that I could do something to a 3 to make it into a 6. What I could do is to times it by 2. And what you do to the bottom, you do to the top. So this one here, I'm not doing anything to him. I'm just rewriting it down there. That's why I'm keeping it in blue. On the other side, the one that I'm working with in yellow. 1 times 2 is 2. 3 times 2 is 6. So now what I've done is I've used an equivalent fraction, because those two are the same. The ones on the left are equal to the same. We've just drawn them differently. I've now made my denominators the same so that I can tick my first rule. Now that my denominators are the same, I can add it just like what we were doing before. So I can say the denominator stays the same. 2 plus 1 is 3. So my answer is 3/6. All right. Just said it again. I'm really not doing very well. The second one we're going to do. 1/4 plus 1/2. 1/4 plus 1/2. First rule, we have to make our denominators the same. This time, I notice that I can do something to the 2 to make it a 4. If I times it by 2, I can make it into a 4, and you've got it. What you do to the bottom, you do to the top. So this fraction on the right now becomes 2/4, 2/4. The fraction on the left stays the same, 1/4. Now that we've got the denominators being the same, we can add them. Denominator stays 4 because we don't add the denominators. 1 plus 2 is 3. And there's our answer. One more together. And then you will try 2 on your own. So each of these we've had to times by 2. I've chosen another one where we won't times by 2. We will times by something else. Just to show you that it's not always the same. This one. If you'd like to try and get ahead of me, you're welcome to. I will work a little bit slower to give you a chance. 1 over 10 plus 1 over 2. I quite like laying everything out before I even start writing things down. I have noticed that this 2 could be times by 5 to make it a 10, which means I've got to do the same to the top. So on the right, I get 5/10, and on the left, unchanged, 1/10. Denominator doesn't change. 1 plus 5 is 6. There we go. Number 4, you're going to try on your own. I'm going to give you about a 40-second head start to get this one done, and then I'll work through it as well. Don't forget your rules. Before we add them, we need to make the denominators the same. Right, if you haven't managed to finish, follow along. You can see how far you got. You can finish it off, and hopefully we'll learn from it. I noticed that I can do something to this one to make them the same. I end up with 2 over 8, 2/8. On this side, I leave it unchanged. Now that I've made my denominators the same, I can add them. Denominator stays as 8. 2 plus 3 is 5. There's my answer. Last one. Before you can get onto your homework and try these on your own. So 2 over 6, or 2/6, plus 1 over 3. So I think perhaps the thing that's possibly catching you, or catching some of you, is not knowing what do we times one of them by in order to make it the other. And the better you know your times tables, the easier you'll find this. So when I look at 3 and 6, I know that they're both in the 6 times table. So I've just got to times this to get it to be this. But the more you practice your times tables, the easier that will become. So, leaving the one on the left unchanged, 2 over 6, or 2/6, making sure that I do the same to the top and the bottom on the right, I end up with 2/6 as well, and that's because 2 over 6 is an equivalent fraction for 1 over 3. Now that my denominators are the same, I can add them. 6 stays as my denominator, 2 plus 2 is 4. And there is my answer. I hope that is making sense. All right. 5 times. By next lesson, I hope to have it down to none. Thank you for joining us. Remember that if you have any questions, email me on grade4@worksheetcloud.com. The homework you can find, it's really just a way to see that you've understood what we did during this lesson. You can find it by clicking on the link above. The answers are there as well. But if you prefer to wait until next lesson and mark it as we go through it together, you're welcome to do that as well. I hope you have a fantastic afternoon, and I look forward to seeing you again tomorrow morning. Goodbye, grade 4s.